Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today I will continue on our lecture in Introduction to Hypothesis. So we will focus on hypothesis testing for two population mean for dependent samples. For last class we already looked into independent samples. So today we're going to look into independent sample. So dependent sample means that we are collecting on the same respondent or the same observation two times or three times or many times, right? So we are collecting the same data, same observation many times, right? So let's look at the hypothesis statement. So let's say we have a two-tail test, right? So two-tail test for dependent sample, two mean for dependent sample, null hypothesis should be mu1 equal to mu2, which is no difference. Right? For alternative hypothesis, it should be mu1 is not equal to mu2. This is to indicate there is a difference between previous observation and next observation, or we call it pre-test or post-test, right? So for one tail test, for this is for right tail, so let me draw for two tail test. The distribution will be look like this, right? So there will be a two rejection area. So this one on the left hand side, and another one is for right hand side. So this is a rejection area, and this is what we call as acceptance area. So this is the same area on the left hand side is also a rejection area. So one tail test, this is for right tail. For right tail, the distribution will be look like this on the right hand side lah. Right, so I think this one I already mentioned before in previous topic also, right? So this is a rejection area. So the rejection area is on the right hand side. So the null hypothesis, the null hypothesis are same as two-tail test, right, which is there are no different. But the difference in alternative hypothesis, where the mu1 or group number 1 is more than group number 2. So the same concept is also applied for left tail test. Right, this is for one sample, two dependent sample, one tail test for a left tail. Alternative hypothesis will be mu1 is less than mu2. So this is for left tail test, right? So the distribution will look like this. So the rejection area should be on the left hand side. So this is a rejection area. So I think this is the most basic that we already learned it previously many times, right? So to identify where is the region of rejection region on either in the left hand side or right hand side or both side, right? So the test statistics that we're going to use is a t-test, which is t distribution, but the difference is we are using t equal to d bar minus mu d divided by standard deviation, or the difference divided by square root of n. So d bar is the mean difference, sample mean difference. So mu d is the population mean difference, which is always equal to 0 lah, because if you are comparing two-sided, they should be equal to 0. If you look at this one, right, the first hypothesis, the first statement here on the left hand side, so it is always equal to 0, right? Always equal to 0. So that's why mu d should always equal to 0, right? And the d bar is the difference, the mean of the difference. So we need to compute the difference between pre and post test, and taking the summation divided by number of observation. So this is what we call as d bar, which is the mean difference. And then there is a standard deviation or standard standard deviation of the difference. Right? This is a standard deviation of the difference. Means that the summation of d squared minus summation of d then u squared divided by n, and everything divided by n. So the degree of freedom is n minus 1, which is the number of observation minus 1. So this is for t-test, we need to divide by standard error of the difference. Right? So then, as we already learned in previous chapter number 3, right? The confidence interval for the difference is given by, so mean difference plus minus t alpha divided by 2 with degree of freedom. So never forget with degree of freedom, alpha divided by 2 with degree of freedom, and multiply with the standard error. Standard error is a standard deviation of the difference divided by square root of n. Right, so make sure you make a correction on this sentence. Right, standard error of the difference should be actually is a standard deviation of the difference. Okay, let's look at the example. Right, so the data shows student marks over 30, right, for pre-test and post-test. Right, so for the same student, we are collecting two data point, which is a pre-test and post-test. Right, so for the new teaching method introduced by the lecturers lah. So to analyze the data, right, so before we analyze the data, we need to look at the data first. We need to understand whether the variable involved here is a dependent variable or independent variable. Independent variable means that we are collecting the data on a different students, right? So in this data, we are collecting the same student. For the same student, we are collecting two data. Right? So means that pre-test and post-test data came from the same observation or same students. So these two variable we call as a dependent variable or dependent sample. Right? So next, after we have the data, we need to compute the difference of two data. Means that 18 minus 22, it should be equal to negative 4, right? 18 minus 22 equal to negative 4. So this is the difference between pre and post data, right? Because our t distribution, right, is equal to t minus mu d divided by sd over square root of n, and we need to have the value of d bar. D bar is the different mean difference, right? So the mean difference is calculated by using summation of d, right? Summation of d divided by n. So negative 41 divided by 20. Where do we get negative 41? Means that for every difference value that we got from each observation, we're going to sum up, then we will get negative 41. So negative 41 divided by 20, so you will get negative 2.05, right? 2.05. So then this 2.05 is called as mean difference. So this is what we call as mean difference. Mean difference. So this is the requirement that we need to get before calculating the result. Or there is another method, right? So instead of calculating for each difference, we can get the mean of the mean of pre-test and mean of post-test, right? Then we take the difference between mean of pre-test and mean of post-test as this formula shown. So if you get the mean of pre-test 18.4 minus mean of post-test 20.45, so we will get the same result, which is negative 2.05, right? So next we need to calculate the d square, right? D square is the square of each difference, means that -4 squared is equal to 16. -4 squared equal to 16. -1 squared equal to 1. -2 squared equal to 4, and so on lah. And then we will need to have the summation of d squared, means that the summation of all d squared will be 1237. So from this summation of d squared, we will calculate the standard deviation of the difference. Standard deviation of the difference, right? So standard deviation of the difference are same. We are using the same formula as the standard deviation, but we only change the value of x square, summation of x square, to become summation of d squared. Right, so summation of d squared minus summation of d, and then you square divided by n, and everything divided by n minus 1, taking a square root for everything. So you will get the standard deviation of the difference, which is 2.8373. Right, then from the standard deviation of the difference, we need to find the standard error of the difference. So standard error of the difference. So standard error of the difference is standard deviation of the difference, right, divided by square root of n. So this is the same requirement for t distribution, right? So then from here we can calculate the 95% confidence interval for mean difference. So this is for dependent sample. So the formula are same as previously we already learned in chapter number 3 in confidence interval, right? So standard deviation, confidence 95% confidence interval for mean difference. So we need to put the mean difference plus minus t alpha divided by 2 with degree of freedom. Our degree of freedom is n minus 1, and multiply with the standard error, which is the standard deviation of the difference divided by square root of n, right? So from here we can input the data, which is negative 2.05 and t alpha 0.05 divided by 2, which is t 0.025 with 90 degree of freedom is 19, and standard error of the difference is 0.634. So then we will get the confidence interval for the mean difference for dependent sample, right? So let's move to the next page, which is this is the confidence interval for the difference of two mean in SPSS output. This is for two dependent sample mean. So as we can see, SPSS will provide us two tables. First is a paired sample statistics, another one is paired sample test. So the table are quite different in previous topic. In previous topic, we are discussing on independent sample tests. Right. For this topic, we are considering paired sample or dependent sample statistics. Right. So for the first table, they are giving us the mean for each test, pre-test, the mean for pre-test, the mean for post-test, standard number of observations, standard deviation, and standard error of the mean. So this standard error of the mean are obtained by standard deviation, right? This standard deviation divided by square root of n. So if you put into the formula, right? So we will get 3.152 over square root of 20, right? Same goes to the next row, right? Alright, so for post-test also same, right? So standard error of the mean are getting from standard deviation divided by square root of n. So let's move to the next table, which is paired sample table. Alright, paired sample test table. So this is a paired sample t-test. If you can see, the title of the table is paired sample test, and they give us the paired difference here. So the first row is pair number 1, which is the difference between pre and post variable, and this is the mean difference, which is the mean for pre minus mean post. So if you can see 18.4 minus 20.45, so you will get negative 2.05. And this is a standard deviation of the difference, right? Standard deviation of the difference, which is 2.83. If you can see our calculation also same, right? So this is a standard error of the mean, right? Standard error of the mean difference, right? This is a standard error of the mean difference, where the standard error of the difference, right, divided by square root of n. This is not equal to standard error of the mean from the previous table. It's not equal, right? It's not equal, right? So is this actually a standard error of the difference, right, for the mean. And then we have another column which is indicate the 95% confidence interval for the difference, right? So this is the same calculation that we have got previously. Negative, so d bar plus minus t alpha divided by 2 n minus 1 standard error of the difference. So we will get the standard 95% confidence interval, right? So this is getting from here, right? So you need to change the line here, right? So this is a t distribution, right? T distribution or t statistics. So this is getting from d bar minus mu d divided by standard error of the mean, right? Right. So for t-test, test statistics, mean of the difference, mean difference that we got from here, right? Minus 0, which is we notice that null hypothesis mu1 minus mu2 is equal to 0, or we can say mu d is equal to 0. So that's why 0 is taking place in this formula, and divide by standard error of the difference, which is 0.634, right? So this one, so we will get negative 3.23. So note that this one is already told you. Note that mu d is always equal to 0. So the hypothesis testing should be mu d equal to 0 and mu d is not equal to 0. So for looking from the table, the critical region, a critical value is t alpha 0.05 divided by 2. It's supposed to be divided by 2, which is equal to 1.833. So since the this is I think the different formula, right? So different example here. It's supposed to be negative 3.231 less than negative 1.3833. So we reject null hypothesis. So this one you can conclude that there is a significant difference between two means. So this is for critical value approach. If you are using a p-value approach, so we just look into a p-value which is 0.004, right? So 0.004 is less than 0.05, so this is 0.05, not 0.005. So since the p-value is less than 0.05, so we reject null hypothesis, then we can conclude that there is a significant difference between two means. So the same, the critical value approach and p-value approach are same. The concept are same as we had discussed previously. So now let's look at example number 20, right? So before we go further, let me show you how to key in or get this output from the SPSS, right? So let's say I already have the data in SPSS, right? So I already key in the data in SPSS. So I need to go to analyze and click on compare means, right? And then click on paired sample t-test. Analyze, compare mean, and paired sample t-test, right? So you will get this dialog box, right? So on the left hand side is your all the variable in the data set. On the right hand side is the variable to be analyzed, right? We just input pre into a variable 1 for row number 1 and post into variable number 2 in the same row, right? And then for option, we just maintain 95%. Otherwise, if you want to measure 99%, you just change it to 99%, right? And then we don't want the estimate effect size and click OK. So then we will get the result. So just we need to wait for a while. So this is the result for pet sample t-test. So in the newer version, they already give you the additional table, which is a pet sample correlation. So we can delete this one. We don't want the second table. So this is the result that we got from the SPSS, um, same as the result that we got from the notes, but only different is that we in a newer version they give us the p-value for one-sided and two-sided. That is a new version upgrade, right? So now let's move to example number 20. So in example number 20, a hotel manager is interested in investigating whether the introduction of new internet facilities at 4-star hotel had increased hotel rating. To answer the question, the manager took a sample of customers who used to stay at the hotel to rate the hotel internet facilities. So the variable is that we're going to measure is hotel internet facilities. Scores on the hotel internet facility before and after the introduction, the new internet facility were obtained from 8 customers and were analyzed using SPSS. So we know that we have n equal to 8. So based on the result, I'll put in table number 7, answer the following question. So we have two table here, table number 6 and table number 7. So the first one is table number 6 and the second one is table number 7. Table number 6 is given as sample statistics for pet sample. Table number 7 is given as pet sample test. So basically the result are same, right? But the orientation of the result presented is different. So in this example, we can see the orientation is on white format. This is on long format. So basically the result are same. So now the question is, are both sample customer dependent sample? So we can say yes, because it taken from same customer to measure before and after implementation of internet facility, right? So what is the appropriate statistical test that can be used to analyze the data? So if you look at this one, this already give us the name of the analysis, which is pet sample test, right? So this is not really a complete one. So we look at the pet sample test, the distribution that we are using a T distribution. So we can input pet sample t-test. So this is the correct answer. Pet sample t-test is the statistical test that we are using in this table, in this result. So based on the p-value, so can we conclude that introduction of new facility hotel effective at 0.01 level of significance? So first, we look at the p-value is equal to 0.07. Since the p-value is more than 0.01, which is our alpha, here is our alpha, right? This is our alpha. So then null hypothesis is accepted, right? So it means that there are no difference between before and after. before and after implementation. So then we can say that the new facilities is not effective. The new facilities is not effective, right? Because there are no different before and after, right? Okay. So this is for question number 21. So 20. So let's look at example number 21. So for example number 21, the Bay Resort is one of the reputed resort in at Pulau Kapas, right? Majority of tourists opt Bay Resort for their accommodation. Recently, this resort confronting with the slow performance in their manual reservation system. So therefore, the manager of Bay Resort hired a researcher to investigate whether the computerized reservation system had reduced the average reservation system. So we want to know whether the computerized reservation system had reduced the average reservation time at the resort. So random sample of 8 tourists were selected. The average time taken for reservation before and after using computerized reservation system were recorded. So in this this statement, we know that they want to know whether the new computerized reservation system reduce the average reservation time. So null hypothesis mu1 minus mu2 is equal to 0, right? Or we can say that mu1 equal to mu2, right? Let's put like this way to understand the statement mu2, right? Now alternative hypothesis mu1 is less than or more than mu2, right? Means that this is what we are talking about, mean reservation time, right? So if mu1 is more than mu2, means that the new system is good. So we can put it this way: mu1 and mu0, mu1 minus mu2 equal to 0. H null, H alternative, mu1 minus mu2 is more than 0, right? So this is going to be a one tail test. So this is the result, table number 6 and table number 7, right? So state the hypothesis for the above test. So null hypothesis we already created before, mu1 minus mu2 equal to 0. Alternative hypothesis mu1 minus mu2 more than 0. Show the second question, show how the value of test statistic of mean is obtained. Test statistic for mean is obtained, this one, right? So we need to show this one, t equal to d minus mu d divided by sd divided by square root of n. So mu and different of mean difference is 23.25 minus 10.875 minus 0 divided by standard deviation of the difference. So standard deviation of the difference is 2.21601 divided by square root of n. Square root of n, we have n is equal to 8, so divide by 8. So this one should be, so we just input it to the calculator. So 23.25 minus 10.875 divided by, we have another fraction here, 2.216601 divided by square root of 8. So this one should be 15.795. So it should be 15.795. So we already shown how the t value is calculated. So based on the p value at 10% significant level, so this one should be alpha equal to 0.01. So should the researcher suggest to the manager resort to exert computer reservation system, and what is the implication of researcher suggestion. So if you look at the p-value, this is a p-value, right? P-value. So in this example, it's very bad example. It shows that p-value is 0.00, right? It's supposed to show more value here. So we can say that the p-value is less than 0.001, right? Since it shows that 0.000. So since the p-value is less than 0.01, which is our alpha, null hypothesis is rejected. So since the null hypothesis is rejected, we can say that there is an improvement of mean reservation time for new computerized system, right? So this is how we answer the question. So now let's look at example number 22. So the personal grooming is one of the vital element in ensuring the competency of and employability of students. Due to the reason, all degree of tourism with honors, right, students were required to attend the personal grooming workshop held by the Faculty of Management, Hotel Management and Tourist UiTM. A random sample of 10 students was selected. So average score before and after attending the workshop were recorded. So the previous study indicate that those people who attend the personal grooming workshop is easy to get hired, right? It's easy to get hired. So means that in this situation, we know that the claim is when people are attending the workshop, they're easy to get hired. So null hypothesis mu1 is equal to mu2 before and after. Alternative hypothesis mu1 is less than mu2, right? So the chance of getting hired is more in mu2. So we can put it in a nice way. Null hypothesis mu1 minus mu2 equal to 0. Alternative hypothesis mu1 minus mu2 less than 0. So the question asks us to show the mean obtained d bar. So how to get the mean difference, right? So to get the mean difference, so there are no mean difference shown in this table, right? So since there are no mean difference shows in this table, we can use all available information that available in this table. So such as t equal to 12.897. So let's use this information. So t distribution is actually mean difference minus 0, which is mu different, mu d, right? So divide by standard error of the difference, right? So it's equal to 12.897. So as we know that d bar is minus equal to 0 divided by the standard error of the mean. Standard error of the mean is 2.4 2.40370 is equal to 12.897. So from here we can find the value of d bar. So it should be equal to 12.897 multiplied with 2.40370. So we just use our calculator. 12.897 897 multiply with 2.40370. It should be 31.000, right? So this is how we show how to get the mean difference, right? So the null hypothesis and alternative hypothesis. So we already stated before, null hypothesis mu1 minus mu2 is equal to 0. Alternative hypothesis mu1 minus mu2 is less than 0. So this is less one-tailed test. So based on the p-value, right, at 10% significant level, so this is alpha equal to 0.01, is there any sufficient evidence to indicate that that attending the workshop improves student personal grooming? So p-value from this table is equal to, so again is doing the same mistake. They give us 0.000. So 0.000, it doesn't mean is the p-value is equal to 0. It means that p-value is less than 0.001. So since the p-value is less than our alpha 0.01, this is our alpha, right? The null hypothesis is rejected, right? So since the null hypothesis is rejected, so we can conclude that there is an evidence to indicate the that attending the workshop improve student personal grooming, right? So this is how we conclude the result lah. So if you have the value of mean, then we can support more, we can further support the evidence lah, right? So let's look at example number 23. So in the Fly company organized a training program to boost the morale of its company employee. To measure the effectiveness of the training program, the company selected a random sample of 7 employees and obtained their training scores. So the objective was to decide whether the training should be continued in future, right? So maybe we want to know before the training is the score is lower than after the training. So the null hypothesis will be mu1 equal to mu2. Alternative hypothesis mu1 is less than mu2, right? So we can put it into a proper presentation. Mu1 minus mu2 equal to 0. Alternative hypothesis mu1 minus mu2 less than 0. So now the first question is, it asks us to compute the value of x. The value of x is standard error of the difference. Standard error of the difference is standard deviation divided by square root of and standard deviation of the difference. So this one should be 5.757 divided by square root of n. N is equal to 7, right? So this is our n, right? Equal to 7. So this one should be equal to, let's put it this way, 5.757 divided by square root of 7. So this one should be 2.1759, right? So now using the p-value test at 1% significant level, whether the training has boosted the morale of the company employees. So p-value is equal to 0.006, right? So since this is a one-tailed test, we need to multiply with 2. So this one should be 0.0012, right? Let's compute it properly. 0.0, oops, 0.0, oh, 0.0606 multiply with 2. So because we are doing one tail test, right? So it should be 0.012, right? 12. 0, 1, 2. So since the p value is 0.012 more than 0.01, which is our alpha, null hypothesis is accepted, right? So then we can say that the training does not boost the morale of the employee, right? So say the implication of result obtained. So this is the implication lah, right? So does not boost the morale of the employee. The company are wasting the money, right? So we can see like that lah. So now example number 24. A company would like to investigate if proving cafe facility in its premise would reduce the spend time by its worker during lunch, right? So means that they want to know whether null hypothesis mu1 minus mu2 equal to 0. I say we put like this, mu1 is equal to 0, mu2. The alternative hypothesis mu1 is more than mu2, right? So we can put it into a proper way, mu1 minus mu2 equal to 0. Alternative hypothesis mu1 minus mu2 is more than 0. So a sample of 10 workers was selected and the amount in minutes spent during lunch before and after the company provide the cafe facility were recorded. So we have table number 7 and table number 8. So this is a common table, right? So state 95% confident interval for the mean difference. So 95% confident interval we already learned, mean difference plus minus alpha divided by 2 with degree of freedom and multiply with the standard error of the mean, right? So this is the formula, but the question asks to state the value of mean difference is already here, so we just state the mean difference is 21.951 to 40.049. So we have 95% confidence that the mean difference of before and after is between 21.951 and 40.049. So at 5% level of significance, is there sufficient evidence to conclude that time spent by the worker for lunch has reduced after the company provide the facilities, right? So it should be, so we look at a p-value. P-value is 0.00, which is equal to less than 0.001. Since the p-value is less than 0.05, which is our alpha, right? We can say that the new the new facilities has reduced the worker lunch time, right? We can say that the new facility has reduced the worker time for lunch, right? Okay, so for example number 25 and 26, I hope you can do it by yourself lah. This is a very simple example, right?